Hello and welcome to Calculus tutorial. Right now we're going to take a look at implicit equations and how to take the derivative of implicit equations. Something you probably haven't seen much of before. You don't really study implicit equations too much. They're fairly complicated, and we're going to take a look at how to take their derivatives. So first off, you're probably unfamiliar with that. What is an implicit equation? You're more familiar with explicit equations. That is where y is by itself. Y equals mx plus b is an explicit equation. An implicit equation is where y is not by itself. And so you can see here we have x's and y's mixed up on the left and x's and y's mixed up on the right. And here I used a computer to graph this equation. You probably haven't seen a graph much like that before. And so a couple of interesting properties about implicit equations. First, y is not by itself, and you can't get it by itself. Okay, there's no way we could algebraically manipulate this to make this a y equals equation. Second, hopefully you notice, this graph here shows us that this is not a function. We do not pass the vertical line test. So this is not a function. Another reason why you haven't really studied this before. You've studied functions mostly, and this is not a function. But even though it's not a function, we still want to take a look at it, because if I pick a point, say right there, that point would still have a slope. And that means it still has a derivative. So how can we find the slope at that point or any other point? How can we take the derivative? And so that's what we're going to be doing here, using implicit differentiation. So how do we do that? Well, we have to use the chain rule in a special way. All right, so let's pick a slightly easier implicit equation here, and we're going to find the derivative, which is the change in y over the change in x, dy dx. So how do we do that? Well, we're going to treat this as an operation. Anything you do to one side, you do to the other. So we are going to take the derivative of the left. Make sure you put with respect to x underneath. And we're going to take the derivative of the right. So we're doing the same thing to both sides, just like solving an equation back in Algebra 1. Now, some of this should look familiar and easy. What is the derivative of 2? That's pretty easy. The derivative of any constant is 0. Something else that should look familiar, over here we have addition. So we can take the derivative of the left plus the derivative of the right one separately. So what is the derivative of x? That's also a nice easy one. And it is 1. Plus, now the other one I'm hoping is a little bit odd. What is the derivative of y squared? We have never done that. What is the derivative with respect to x? Oops. Of y squared? Well, to do that, we're going to use the chain rule. And the y is what is sort of confusing. So I want you to change that y and just think of taking the derivative of box. And that's box squared. So instead of the y is confusing, take it out, just the box. Well, how do I take the derivative of a box? Well, the 2 multiplies in front of the box times the derivative of that box. Actually, what I might write that a little bit shorter. Let's just call it box prime. Okay? That's just the chain rule. The 2 multiplies down in front, the derivative of the outside, times the derivative of the inside. Well, what goes on the inside? Y. That was our box. That's what we replaced with box. So the derivative of y squared is 2y times y prime. Now I'm going to write y prime slightly differently. Y prime is the change in y with respect to x. That is y prime. Equals, that was 0 on the other side. So I don't want you to have to do this every time. So how did we go from here to here? Well, we just took the derivative like usual. 2 multiplies down and you get 2y. But then what you're going to have to recognize is that the x and the y don't match. And because they don't match, you have to add dy dx. That is the chain rule working. Again, I don't want you to have to do this whole box thing every time. And so just know that when the variables don't match, you have to add this derivative at the end. Now let's go back to what our question is. Our question is, what is dy dx? What is the derivative? Well, that means I have to get this by itself. I want to know, what does dy over dx equal? Well, that's not going to be too hard. This is a fairly simple equation. To get that by itself, a little bit of algebraic manipulation. Subtract 1 from both sides. You get 2y times dy over dx is equal to -1. And then we have multiplication here, so divide both sides by 2y. And you'll get dy dx is equal to 1 over 2y. And so that is our derivative. So you might see it as dy dx is equal to 1 over 2y, or you might see it as y prime, that's the same thing, is equal to 1 over 2y. Alright, so that's a nice simple example of how to use implicit differentiation. You take the derivative of both sides, and if you have your variables not matching, you have to add that dy dx. Alright, so we got a simple one under our belt. Let's take a look at a harder one. We can use a chain rule. Now let's do some harder implicit differentiation. So let's write the equation of the line tangent to the curve of this big implicit equation at the point 1, -1. So at the point 1, -1, right here. So we want the equation of this tangent line right here. That's what we're going to find. And remember, there's two things you need for a tangent line, a slope and a point. I've given you the point. You need to find the slope. Another word for slope is the derivative. So we're going to take the derivative of the left with respect to x, and we're going to take the derivative of the right with respect to x. There we go. So we have y squared plus y, and we have x minus x squared. Let's do the easy side first. The right side is all x's, and that's what we're familiar with. So the derivative of x is 1. The derivative of -x squared is -2x. Now let's do the other side, where it's got some new stuff. So what is the derivative of y squared? Well, the 2 multiplies down, just like the usual power rule. But because the variables don't match, you have to add, well, put in a dy dx. It is not adding, it's multiplying. The derivative of the outside times the derivative of the inside. And same thing here. What's the derivative of just a y? Well, it is 1. Just like the derivative of x was 1. But the variables don't match. So another dy dx. So again, if we want the slope, we need the derivative. So we have to get dy dx. It's going to take a few steps, so I might have to erase this. but we want dy dx by itself. Now we've got two of them, so how are we going to do this? Well, as you can see, there are two terms, and they both have a dy dx. So what we can do is factor it out. What is left over when you pull out the dy dx? Well, you're left with a 2y and a plus 1 is equal to 1 minus 2x. All right, now this is multiplying here. So to get rid of this whole piece, we're going to divide by the whole 2y plus 1, and we're going to divide it to the other side. I'm running out of room here, so hopefully you can visualize that in your head. So we're going to have 1 minus 2x divided by 2y plus 1. So that is our slope. If it's not super clear what we just did there, I divided this side by 2y plus 1, and I divided this side by 2y plus 1, which meant that went away, and this is what we're left with. Well, I still don't have a slope, because I need the slope at 1, negative 1. And so usually we just have to plug in the x, but because we have x's and y's, we're going to plug in the x, and we're going to plug in the y. So 1 goes in for x, and negative 1 goes in for y. So our slope is going to be 1 minus 2 over negative 2 plus 1, which will give us negative 1 over negative 1, which is positive 1. And because we have a graph here, hopefully we look like we're on the right track. That definitely looks like a slope of positive 1. I would recommend a point slope form, so y minus y, which is negative 1, is equal to m times x minus, in this case, 1. And then if you want to simplify that, you can. That becomes positive. Distribute here, you get x minus 1 is equal to y plus 1. And subtract 1 from both sides. X minus 2. So there is the equation of this line. The slope looked good. That looks like a slope of 1. Does it look like our y-intercept is going to be negative 2? Well, if this is negative 1, negative 1.2, yeah, it looks like somewhere down here will be negative 2. Looks like we're doing okay with our equation. All right, but hopefully that wasn't too confusing. We've done tangent lines before. You need your slope, you need your point, and so you can just use algebra 1 there to get it. The new stuff comes over here. Taking the derivative of both sides. Make sure you add your dy dx's whenever you need to, whenever the variables don't match. And then get dy dx by itself, whatever algebra that takes. In this case, we had to factor it out. That happens a lot. And then you can get it by itself, and you've got your equation here for the slope. As you can see, it takes both x's and y's in that slope. Again, this is an implicit equation. It's not a function. So if we just plugged in x, you wouldn't know if you were up here or down here, which is why you need both x and y. All right, hopefully that helps for implicit differentiation.